Hey, welcome back to another episode of Mr. Lewis Speed Runs Your Homework. It is almost my bedtime, so we're going to go real fast. This time we're looking at problem set 1.4 graphing. So let's open this up. Alright, looks like we're going to be making another graph. Okay, so Jane Physics is rolling a ball up a hill. Using a radar gun to measure its speed, she programs the radar gun to measure it every 0.25 seconds. Here's her data. She wants to find the relationship between the speed and the ball. You can use this relationship by using a graph. Okay, so what is the independent variable? That always comes first, and that is time. Time is independent. Independent always goes on the x-axis as well. Okay, and then second is dependent variable. That's going to be speed. That's the output, which is the y-axis. Oh, no, not time, speed. Speed is dependent, goes on y. There we go. Alright, so next we're going to make a graph. So to do that, we got to open up Excel. You might notice that I'm using a Mac. That is because I'm at home. And I use a Mac at home. Alright, so my buttons might look a little different from yours, but that's alright. It's all the same. Okay, so let's do this. So our independent variable goes in the first column, our dependent variable goes in the second. In this case, we're using time in seconds, and our dependent variable is speed, which is in meters per second. Okay, so we're going to take this data and transcribe it here. So we're starting with 1, 1.25, 1.5, so on and so forth. I'm going to take a shortcut. That way I don't have to write all these. There we go. Okay. Alright, there we go. So there's our data in Excel. What are we going to do now? Well, we have to turn it into a graph. So we got to click, highlight, click insert, go to charts in the middle, right above the word charts. On mine, it obviously doesn't have the word charts, but it's right here. It's always in the middle. Scatter plot, make our scatter plot. Ooh, look at that. That's some good data right there. Alright, so we got to add some stuff in here. On a Windows computer, you'll have a little plus right there that can add these things. If you're like me and you have a Mac, you have to come all the way up here. So probably the worst part about a Mac, the buttons are a little bit less convenient. But either way, we're going to add our trend line. We also need to go to more options, go down to the bottom, and click display equation on chart. Okay. So just to see that path again, if you're on a Windows, you'll have a little button there to do all this. For me, because I don't have a Windows, you'll basically, when you click that window, if you click on the right arrow, go to more options, and it's down here at the bottom. Okay, so there we go. We got our slope, or our y equals mx plus b. There we go. We're going to change the name to be independent versus dependent variable. Independent is time versus dependent, which is speed. Change our axis titles. There we go. Perfect. Okay, so now we got this thing. So the points on the graph essentially form a downward sloping line. Okay, so it's a line that goes down. As time decreases, okay, so as we go from, for example, 1.52 to 1.5, so we're going down, the speed increases, because when I'm at 2, it's about 10, but when I'm at 1.5, it's about 12. So it goes up as the time goes down. So that's going to be increases. What's the slope of the line? My slope is 3.3469. But to round that off, 3.35. Yeah, 3.35. What is the y-intercept? It's going to be 16.766. Oh, wait, that's too many digits. There we go. 3 digits. Okay, basic equation, put on your blah, blah, blah. Okay, so basically we're replacing the y and x with the representative variables. In this case, I'm going to move this down just to explain this a little bit better. So we know that the independent variable is the x-axis and the dependent variable is the y-axis. So we can see those represented in this formula. The y-axis value is equal to this number times the x-axis value plus this number. Okay, so our x is little t, our y is little v. So this says little v, right? Yeah, little v right there. Okay, so we're gonna rewrite this equation right here from the chart over here, just with replacing y with v, because our y-axis value is representing speed, which is the symbol for that is little v. In our x, instead of writing x, we're going to write little t because that's the representation for that. So v instead of y is equal to negative 3.35 times x. Nope, not x, little t, plus 16.8. So we can use this speed to find the speed of the ball at any other point in time. So what if we say at 4.5 seconds, 4.25 seconds? So what we're going to do is we're going to take the time of 4.25 seconds, plug it into this equation. Okay, so I'm just going to drag this over here. Let me get a little notepad so I can draw this out. Alright, so here's this, here's that. Let's do it. Oh no. Connected to the wrong thing. Let's see. Nope, it should be here. Weird. Super weird. Doesn't work. Maybe if I turn it off and on. Ooh. There we go. Whoa. What is going on? I'm like moving it, and then there's like a 5-second delay if it moves at all. Whoa, that's crazy, dude. I'm not doing that. It's just going crazy. Alright, guess I'm not drawn today. Oh, dude, I'm so dumb. I didn't even have that plugged in. Oh, yeah. That'll do it. Now let's try it. Okay. That was so weird. Okay. Okay, V equals... Whoa. V equals negative 3.35 time plus 16.8. Okay, sorry about that delay. So we know that t in this problem is equal to 4.25 seconds. We know that from over here. Okay, so we're going to take that t and plug it in over here for this one. Okay, so we're going to replace this t with that t. So rewrite the equation with the new number plugged in. V equals negative 3.35 times 4.25 seconds plus 16.8. Okay, so we're going to multiply these together first. So negative 14.2375. Okay, this is an intermediate number. This is not our final answer, so we don't have to round yet. You only round your final answers. Okay, so we just add these together. Plus 16.8, that gives us 2.5625, 5625. Okay, but we have to round this off, so we're going to go 1, 2, 3, round into that number, so the final answer should be 2.56 meters per second. Just forget about the units. This is it's going to be a little bit too complicated for me to teach you what all is going on here right now. So just work with the numbers, and just know that because speed was measured in meters per second over here, that your answer should be in meters per second when you solve for speed. There's more to the story here. We're looking for speed, it should be meters per second, but just simplify with that right now. 2.56 meters per second. Okay. How much, so now we're going to do the reverse of that. How much time would it take? So now, now t is unknown, and we're given a velocity of 3.36 meters per second. Okay, so we're going to use that same equation again. V equals negative 3.35 t plus 16.8. Okay, we're going to take this and plug it in there. Okay, so we'll rewrite our equation now. 3.36 meters per second is equal to negative 3.35 t plus 16.8. And don't worry about the units. I don't have time to explain all that to you right now. So we're just rolling with it. Okay. And so we need to get t by itself. First thing we gotta do is get rid of this extraneous number, subtract that on both sides. And I'm gonna get rid of these units too, just simplifying it. Don't worry about the units for now. Those ones will cancel. Okay. 3.36 minus 16.8, negative 13.44. 3.35 t. I just brought this down here. Okay, now we need to get t by itself. Well, t is being multiplied, so we gotta do the inverse function. Inverse of that would be division. Oh, that's a negative. Do that on both sides. Okay, these cancel out. T comes down by itself. Gonna divide this by negative 3.35. 4.0119. Okay, blah blah blah. But this is too many sig figs, so we need to count 1, 2, 3 sig figs. Cut it off there. Divide that, or round that one into that one. So our final answer is going to be 4.01 seconds, because we're measuring time. All right. Yeet. Oh, I forgot units here. Slope of the line. So the slope is measuring meters per second per second. Why is that? So let's just do a little bit of background on graphs. Okay, so we have our x and our y. And we know that a line is denoted by the equation y is equal to mx plus b. Where does m come from? Slope is rise over run. So essentially, you're going to be taking the change in y divided by the change in x. Okay, so our y values in this case, alright, never mind. Our y values in this case were measured in meters per second. Our x values were measured in seconds. So when we take y divided by x, we get meters per second divided by seconds, or meters per second per second. Another way to write meters per second would be meters per second squared. This is a very common unit. This is the unit of acceleration, or the change in speed. So congratulations, you calculated acceleration by doing this. So this slope here is actually the acceleration of the thing. But that's why the unit is the way it is. I didn't think I had to explain that, but apparently I did. Okay, and then the y-intercept is always just gonna, as I said here, y is m over s, because it just has the same units as the y value, so m over s, meters per second. Decent. Alright, that was not a very speedy speed run, but I think there was good info.